Hello, good afternoon, and welcome to today's webinar, part of the 2024 Design Timber series. My name is Matt Milton. I am Editorial and Publications Manager here at Timber Development UK. In a minute, we'll be hearing from the team behind today's great webinar, the Boathouse. Moving on to the next slide. But before we start, I'm just going to tell you a couple of things about us. TD UK is both a fairly new organisation and in some ways a very old one because it was formed in 2021 from the merger of the Timber Trade Federation and TRADA. So bringing those two organisations together, we represent pretty much everyone who works seriously with wood and timber in the UK. So we represent everyone from supplier to specifier, architects, engineers, contractors, craftspeople, and everyone in between. We have three key missions to connect the supply chain, to lead best practice, and to accelerate a low carbon future. And here you can see some of the many ways in which we carry out those functions. We have two magazines, designTimber, you can see there, which is our quarterly magazine for all our design members. We also have a sister publication called designTimber, which is for all, as you'd expect from the name, all our supply members. We have a wealth of resources in our resource library. You can see one of our case studies there. That's the Durley-Chine Environmental Hub. You can also watch a webinar about that particular project on our YouTube channel, but that's just one of hundreds of case studies that you can find on our website. You can also see one of our timber knowledge sheets there, 2024 embodied carbon data for timber products. We have a knowledge library with over 70 timber knowledge sheets in it, and by the end of the year, there'll be over 150. They provide introductions to pretty much every single timber-related topic you could possibly want to read. You can also see one of our many publications there. That's Timber Policy, very appropriate in an election week. That particular publication examines different international and national and regional policies that different countries around the world have adopted in order to accelerate timber. But we have all sorts of books and publications on our site that are free for members to download. They include our 3-volume timber design suite, guides to CLT, and all sorts of other interesting things. So we do encourage you to make the most of all of those fantastic free to download member resources. If you're not a member, of course, we'd love to have you with us. If you work with wood, you really do belong. We've just recently launched a valuable member resource called Find Your Timber Partner, which is effectively a shop window for your business. It allows potential clients, potential customers to find out all about you and what you do. And it's a great way of sort of building bridges between what your practice does and other TD UK members. So that's just one of many resources that members gain and that are member only. So we do encourage you to join us if you're not already a member. Here you can see some of our upcoming other webinars in this series. The Eton Sports and Aquatics Centre on Wednesday the 7th of August and the NNIS building on Wednesday the 11th of September. You can register now for those. But now I will hand over to Jeremy, Laurie and Luke to find out all about the Boathouse. Thank you very much.
Thanks very much. So just first, we thought we'd better do some introductions so people know who everyone is. I'm Jeremy Ashworth, Director at Ashworth Parkes Architects, and I was responsible for the sort of concept, initial design, getting through to planning, a bit of sort of notional engineering in my head before I handed over to the more sort of technically adept people in our team. And the first of those would be Luke.
Yeah, good to meet everybody. Thanks for coming. My name's Luke Copley-Wilkins. I'm the Managing Director of Carpenter Oak. So we are designers and makers of timber structures, and we built the boathouse. So we designed it, took the concept drawings from Jeremy and his team, and did the detail work on that, did the detailed drawings, the manufacture of that, and then we supported Laurie with the installation on site. So I'll hand over to Laurie.
Hello, thanks for coming. Yes, my name's Laurie. I'm the director of Enerphase Construction. I am a carpenter, so I was building it. I started doing sustainable buildings. This was probably the last project before I ended up putting my tools down, and now I point at things and show other people how to build things for a living. But this was my last carpentry project that I've done.
Great, thanks, guys. I'm now going to share the screen. I'm driving the presentation, so if you just bear with me while I put it up. Hopefully, everyone can see that. Luke, Laurie, you can see that.
Yeah, perfect.
Good, good. So I'll be driving this presentation. So at some point, you will hear Laurie and Luke saying, "Next slide, please," and that's my instruction to move forward. Hopefully, it's going to be more like a conversation than an actual sort of dry presentation, and that's very much how the building came about. You can see the plot here of where the grounds of the house are, and they're just opposite Stourbridge Common, which is over here, and the River Cam running through from Stourbridge Common towards the centre of Cambridge. The red plot is where the boathouse was situated, and there was an actual inlet there already. The client is both a friend and colleague, and we had worked with him before, so there was a degree of trust already. And as with all of our meetings, the first meeting was over a bottle of gin. And we decided, well, what is a boathouse? And in the end, we decided that the function of it is quite limited. It's protecting the boat from a degree of weather, but it's actually, in the end, a bit of a folly. But it's actually a folly that's in one of our more public locations that we've ever done. So there's a bridge over the river here. Cyclists from all outside Cambridge cycle along here, as do pedestrians. And at the weekends, Stourbridge Common is full of people walking, cycling, running past. So it's a very public building. So we decided it had to look beautiful. We decided as a folly, it had to be very sustainable and use a minimal amount of materials. And I took that as an opportunity, having worked with Joel before and knowing that he trusts what we do, to use it as an opportunity to do some exploration into Japanese joinery. And very early on, we came up with the concept of using as little different materials as possible. And would it be possible to design a building without any metal mechanical fixings and using Japanese joinery techniques? So the first thing I did was to buy loads of books about Japanese joinery and try and interpret those into a form of a building that would allow us to construct it easily. One of the other stipulations was that, as with previous projects we'd done with the client, he and his friends, which included us, wanted to be able to build the building ourselves, or at least have some part in its construction. So this kit of parts actually helped fulfill that part of the brief. So I then sort of used SketchUp because, you know, I'm an architect, so we don't have very complicated Revit or other software like that. We have Vectorworks, SketchUp, and a bit of 3D rendering stuff. So I designed these joints in SketchUp, some of them more complicated than others, and came up with a framework for the building. One of the things we decided was that the easiest thing would be to build a series of repeating frames, which minimize the spans, minimize the complexity of the drawing. But as you can see from this post here, which we have several of these along the facade, has several different members joining in at one point. And we came up with a design concept, got it through planning, and then we came to the sort of situation of how we actually support the building off the riverbed. And we wanted to do that in a way that, again, minimize the use of materials. And was there a way that we could use recycled materials? And I'll probably pass you on to Laurie now, who's in the bottom right-hand corner, who can explain some of the way we did that with the scaffold poles.
And
Well,
just before you do that, I realised I had not brought everyone's attention to the Q&A box at the bottom. So I would just like encourage everybody who's watching to do make a note of the Q&A box. And if you have any questions throughout, feel free to ask them. Sorry for interrupting. Carry on, Laurie.
no problem at all. So, as you can see, the cut there was, well, I mean, the cut was already there. It got incredibly overgrown. And after starting to pull away some of the greenery, the only thing that was left, in fact, as Jeremy had pointed out, was some scaffold poles. There wasn't many, just 2 or 3, but they would obviously been put there 30 plus years ago, and they were in fact still standing. That is the proof that Joel needed to go forward with this particular idea. And what was happened is to build this project, you needed some sort of, well, you either go with concrete or piles or something along those sorts of lines, all of which were completely ruled out on this particular project. And we came towards, in the end, using hand-driven piles in the form of scaffold poles. So the grid was laid with scaffold poles. They were hand-driven into the ground. The scaffold poles were reclaimed from the scaffolders once they get to a certain age and get to a certain amount of cutting off the end and below about 2.4 meters. They have a habit of being taken to the scrap merchant. So we took those, we knocked them into the ground, we put a jointing beam on them, cut the nut off, keep poking with the ground to approximately 4 meters. There are pairs of them on each different point. And then on top of the, thank you, Jeremy. And on top of the scaffold poles, there is a spreader plate. The spreader plate with a, I've got one here, I don't know if you can see on here, but with a screw on it. So we turn this upside down, we put this on top of where we are, because eventually this building is probably going to move. And as it does, this gives us the facility to be able to adjust it as it goes along. On top of these points, we built a subframe out of timber that was screwed together. And it was placed on all the points, as you can see here on the picture next to the heron. And that was put up, leveled up, and that was sat on top of our grid scaffolding system. And that is the base of which we put our system on. You'll be pleased to know that a lot of that has been done from inside the river. So that was done mostly at -10 in a pair of waders. So it was a very memorable project, if for the loss of my toes.
Yeah, and that's the stage where Carpenter Oak came in with their building later on. However, before that, these are just some drawings which explain the system, and I think the timber development will be sharing this talk afterwards. So and we're happy to share any drawings, and these drawings explain how things went together. So after I had done my initial drawings, we then went to a company called Element Design. Part of the joy of this project is that the client knows a lot of people. So went to college, or his wife went to college with people from Carpenter Oak, and he went to college with Sam from Element Design. And what
That's
Element
not quite. Sorry, let me jump in there. It's even more even more nepotistic than that. Joel is in fact the client is in fact my brother-in-law, and Sam is my friend from school, and he was in fact the best man at my wedding. So this is it does get very
yeah.
very
So Sam was able to take the project and take it a stage further in the terms of the engineering. What was very nice from my point of view was actually there wasn't a massive change in the actual design of the joints that I had come up with. So that was reassuring, and the what their work with Revit did was that it tested all of the strength of the joints, the wind loading, and made sure that the building would stand up and would be able to resist things like uplift and to stay in position on the river. So there was a lot of, he also began to refine some of the joints, like on the curved rafters and how they might be fitted together, which again, a stage further down, Carpenter Oak took and ran with. And then there's a series of detailed joints. This explains the boardwalk here. So this is the base of the raft, which you've already seen with the hatches on. Then our building sits upon that, and then there's a timber member that sits between, and the boardwalk sits on top of that. Each of these boardwalk elements can be removed so that it is possible to actually get access to the scaffold plates that Laurie was talking about, and the ability to adjust the height of the building if needs be. We haven't had to do it yet, but do it from the dry. And just to explain, Laurie will explain more about the screens later on. These again are timber screened with which are notched and tenoned, and again use no mechanical fixings. This shows the detail from Element Design of how they would split the timber rafter. Again, that's done from the point of view of minimizing the amount of timber and the amount of timber wastage. If you see, if we did it in one piece, the piece would have to be very large in depth and very long. But you can see in the orange here, we actually sized the bit of timber that would come from, and the blue box at the top, the bit how big the timber from the top piece would come, so that we weren't using too bigger sizes of timbers and actually being wasteful in that way. So we're trying to minimize the waste of each bit of the building as we go along. And now we're moving on to some Carpenter Oak drawings. So I'll hand over to Luke.
Thanks, Jeremy. Yeah, and I think, as Jeremy was saying, Jeremy and Sam put a lot of work into the design really early on, and I think that was testament to the project, because the design intent continued all the way through. So when we took it on from Sam after those initial drawings, we did do a little bit more detailed work just in terms of the connection design and refining that to ensure that when it came to site, it was buildable and it was really simple to install. And we're conscious of that. So there was a little bit more work that we did on CAD, and we worked with Jeremy and Joel and the team to make sure that was suitable. And equally, there are a couple of kind of finite points, like the common rafter connection. We hadn't quite detailed how we would how those would connect. Obviously, Jeremy's already talked about the design intent, and that was early on and carried right the way through was no mechanical fixings for the project. So we came up with we used traditional carpentry joints that are both English, taken English jointing systems that are sort of inspired by the Japanese design intent that Jeremy had. So this scarf, that as the timber shrank a little bit, it could be tightened up if it was needed. Turn on to the next one, Jeremy. So these were our sort of early stage models that we worked with Jeremy and Sam, just in terms of those key connections. So the where the post and the bracing members came in, there was quite a lot of timber and joints in one location. And our concern was not necessarily about the strength of those. That was fairly easily resolved. It was actually how you put it together on site safely, and how do you get all those components together. So we worked a little bit with the team that were going to put it up, and from an in-house perspective in terms of how we'd actually make it, to just refine some of those details a little bit. But really, it really didn't change much. I think there was a couple of pieces that moved slightly from those early stage concept drawings that Jeremy had done for planning. Do you want to go on to the next one? So as Jeremy and Joel have been and Laurie were saying earlier, is that there was a key driver here was sustainability for the project. So when we got involved, we were asked, actually, what material should we use? Where are we going to source it from? How do we make sure it hasn't come from, really far away? So we looked at using different types of timber. I think at one point we were even looking at using glulam and what the different options were.
Luke, can I just say one thing as well, that just for a bit of background information. So when this was built, it was just at the cusp of the war in Ukraine, and before Carpenter Oak became involved, we actually had been looking at what timber we should be using, just again to sort of feed into the element design area of thing, because again they feed in what timber they're using into their model. And we decided upon larch quite reasonably. And one of the exercises we did, the client's very interested in this sort of thing, was to find out how much energy was used to get the larch to site. And we curiously found that actually getting your larch from Siberia used less energy per kilogram of timber than it did in getting it from Scotland. And that's because the timber from Siberia goes on massive trains. So a huge amount of timber gets transported. Then a huge amount of timber gets transported to Felixstowe. And then there's one lorry from Felixstowe transporting it to Cambridge. That was the notion, whereas it comes all the way by road from Scotland to here. So that was just an interesting thing that we found out. And then actually we then engaged with Carpenter Oak, who came up with an equally good solution from themselves. Luke.
Yeah. So we ended up getting it from, as Jeremy was saying, there's a conscious about sustainability and making sure it was that was really an important choice. So we work with a number of local sawmills, and this one is we're based down in Devon, and whilst Cambridge is far away, it's not that far, and we use a really local sawmill to us. It's about 30 minutes away, and all of their timber comes from pretty much the Devon, Somerset, Cornwall area, and this does as well. So it was really important we could use local timber, and there was also very conscious about how much sort of machining went into it. So to reduce the amount of environmental impact, amount of energy that's gone in, it was left as sawn timber. So there wasn't any planing or kiln or drying of it. It was just sawn timber. And we were conscious of that through the design phase to take into account some of that shrinkage. So some of those details that we were showing earlier needed to bear that in mind whilst when we were designing it. So then we made it in our workshops in Devon. So everything was put into component drawings. So those drawings that we were showing you earlier, they were broken down into components, whether that was layups or roof layups or wall layups. And we cut everything in our workshops down in Devon, and we fabricated it all completely off-site. So that made it a lot easier for the team on site when they came to install it. So everything was pre-cut. These are some of the common rafters getting cut. And then from there, the project got completed, put together, and shipped up to Cambridge to get installed by. I'll let Laurie and Jeremy talk about that.
Yeah, so just to say that yeah, we were left with the base that Laurie had built sitting on the scaffold, and then the lorry arrived with all of this timber for the project, and we all helped to build it. So we built the superstructure, which you can see at the bottom, over a weekend. We started on Friday morning and finished Sunday afternoon. And I think there were probably 7 of us, Laurie, if I'm correct, 7 of us and 1 telehandler. And as you can see here, every bit had been scribed with little marks which show what piece joins what. And we also had these very handy color-coded drawings that Carpenter Oak had provided, which gave us the order in which to build the building. But Laurie will take it on from there.
Well, as Jeremy said, so I've worked on many sites over the years, and people generally very much stick to their specializations, whether they're designers or architects or structural engineers. But here it really was like a barn raising, and everybody got involved. So as Jeremy says, Jeremy had his gloves out lifting bits of timber. We had the photographer holding the other sides of the tape measures. Everybody was involved, and I've never experienced something like that before. And it's led to an understanding of the building process for everyone, I think, so much more significantly than I think I've ever worked on before. Yes, as Jeremy mentioned, it was all labelled. We learned that from what the left-hand side of the building, it was all labelled with curved Roman numerals, and the right-hand side, it was all straight. And this is something I'd not come across before, but has since now. Can't walk around an old building without spotting exactly the same system. So I'm pretty pleased it still exists. Yeah, we got it up in well, it was 2.5 days. The superstructure went up on the first day. We then started on the rafters on the second day. And then from the Monday onwards, I was pretty much on my own. I had one other person to come and help me. And that is when we had to start getting the rafters on. The building wasn't perfectly straight when we pushed it on. And the rafters have to go exactly the right place. Otherwise, they will start popping off. So the only way we could get that to physically work is by getting a lot of very significant ratchet straps. We twisted the building and pulled it all in line as everything else went in. There was a lot of drilling out holes to get our wooden pegs in as well to hold the rafters in place. And being that you weren't allowed to use any screws or anything, that made the job significantly more difficult, because you can't just pull the building and tight to each other. It has to be sitting perfectly before you can peg it. After that, we then
started. I also say, Laurie, I think the fact that, as you say, the building has to be perfectly square before it's pegged has led to a very minimal degree of movement in the sort of 2-3 years since the building has been complete. As far as I can see on my recent visits, it's still perfectly square, and we haven't had to level it up.
I think it's tighter now than when we built it. I think it's more rigid now. Now it's getting together. I'm sure there are splits and things in it, but it's all part of the look of it now. It's very nice. This brings us neatly onto our sarking boards. So the curved roof was on. We then have to put an actual roof on it, and so we need to put the sarking boards on, which are there. And now, at this stage, we were just going to admit defeat and use some nails or screws, but it just seemed like such a sort of compromise. And we got this far to try and design it. So after a bit of research, we found that there is something called a lignalock, which is a wooden nail gun, which is there right in the middle. So that fires solid pressure treated beech nails. Got them here in front of me, if you can see them. Solid beech nails into the wood via an airline. Now it was brilliant to a point. And it meant that we could, in fact, carry on with the roof and just build it as follows. As the nail fires in, the heat of it expands the nail, it warms up and it fixes into place. If you try and hit them with a hammer, doesn't really work. If you use the nail gun, works amazingly. They didn't actually exist, any of them, in the UK, however. So it took quite a long time to be able to source one and then source the nails individually. I think the nails ended up being approximately 11p each. And you can see that there's quite a lot of cycling boards on there. So that wasn't, I wouldn't say it was necessarily the cheapest option, but it held true and it works perfectly. They're not moving, and we got to follow the honesty of the project and not put any metal fixings in it, which was absolutely delightful.
And one of the additional advantages of the wooden nail is that because of the resistance, they become very hot as they're forced in, and that releases some sap, which also acts as a kind of glue, an additional means of fixing.
Absolutely. We then had to do the similar sort of idea for the floor. So the floorboards are, as you see, they're you make a little frame and you just drop them in, and you use the nail gun to pin them into place. You get a bit of creaking now still because it's still moving wood on wood, but it's all part of the sort of honesty of the building as you walk around. It is great fun. Once that was done, we handed it over to the roofers, and they used their recycled. I don't know much about the copper, Jeremy. I'm hoping.
Yeah, so the copper is 100% recycled from other buildings. Is fixed with the standing seams being crimped together. So the theory is that if ever it should happen, the copper could be taken off the roof, taken away and recycled in much the same way that theoretically the building could be taken apart, taken off site, and the timber used for something else. And that was, again, part of the criteria that the client had put on us: use as few materials as possible, and where possible with the scaffold poles and the roof finish, make them recyclable, but also make them easily demountable so that they could be reused again should that ever happen. Laurie, do you want to talk about the screens at the side? So
yes.
just a bit of background. When we were working with Element Design and as architects getting a bit ahead of ourselves, we did think of having these the side screens be openable in sequence with a mechanical winding mechanism inside, and so that they would be hinged at the top and bottom opening up, so they would be sailing away from the building like wings. Sam from Element Design actually made this work in the Revit with all the strains and stresses that would cause, but it was one thing we couldn't actually get past the client, who's got two little daughters, and the notion of a 2.4 meter high panel hanging out over his daughters was too much for him. So we then came up with the notion of the panels being removable in the summer, so that they can be taken out and people can access the boat easily, or as in the previous slide at the bottom, it can be used for a kid's party. So yeah, if you want to just explain how they were constructed, Laurie.
So we did have a little bit of head scratching on this, because trying to work out, the only brief we were given is that it has to be able to be moved and adjusted by two normal people. So it can't be heavy, you can't use any lifting equipment, and it's just got to be easy, right? It's just got to work. What we did in the end is, as you can see here, it's that we used the larger timber for the picture frame. There we go, larger. Thank you very much. Perfect picture. We used the larger timber for the picture frame, and we had all these spindles, which we had to make absolutely perfect by running through the table saw. We're making sure that we followed the camber of the timber on every single one, because there's only 3 points of contact. So you've got the top and the bottom and the center. They all lean inwards and the center beam leans outwards. So even as the timber moves, it holds itself together. The way we got them to stick in the top and the bottom is we hand cut all the mortises. And actually, the first one took a little time, but in the end, we got there. I think there was 852 hand cut mortises by the end, so we got pretty good at it. To hold them in place, so there are 2 dowels on the top, and there are 2 holes seated into the beam above it. You probably can't see here, but there's a few spaces on the bottom and a few little feet that it sits on as well, so it doesn't just sit on the water and rot out. And that works really well in that you just have to lift it from the bottom, or just lift it and swing it out and drop it down. Every single one is exactly the same. So when you can take them out and stack them inside the building in the summer mode, or put them wherever you like, but each one can be dropped in and put into any of the other cells, with the exclusion to the end because they're slightly narrower, but they work in the same way.
And testimony to your work, the fact that they have remained perfectly square as well, and fit in all the openings easily over these past couple of years.
Yes.
Not for you to say, is it? Yeah.
Yes, it all worked very satisfactory.
Yeah.
There's been a couple of adjustments where, as I say, so you have to make sure you get the crowns the right way around on all of the timber. And there was 1 or 2 which I must have missed. So I have retrospectively just gone in and flipped them over because I obsess about this sort of stuff. But yes, now they all still run perfectly in line, even with, I mean, the pressure on the timber there, you can see the sunlight coming straight in is hot, gets a lot of sun very quickly. It's right on the river as well. It's outside. So the pressure in terms of having moisture coming in, getting rain coming in, heating up, drying up, it's significant. If there is a way for that stuff to move, it will, and it hasn't. So I'm absolutely delighted.
Yeah. And just going back to an earlier point, if you can see it on the on your screens, you can see the Roman numeral chisel marks from Carpenter Oak here. So there's a V for a number 5. This is number 5 post, and this is number 4 post in the middle, and you can see 1, 2, 3, 4, 1, 2, 3, 4. So we knew which way to put each member, and which post that was going into. And here we have number 3, and they're all done by chisel marks, which was really helpful and satisfying to work through.
And a testament to Luke on that one as well. Of all the timbers that went in, I think we adjusted one ever so slightly by about 2 mil off one joint, and every single one of them fit in perfectly.
Yeah.
Other than that, and it was very impressive. It was like very high risk Lego. Yeah.
And what we find interesting is we have ended up with a fairly traditional looking building, but it's been built in a very traditional way, but it's actually had a lot of testing, technology, design go into it to make sure it functions and is a lasting building for the client. The last thing we would ever want to do is to embark upon an intellectual exercise that benefits our experience but doesn't leave us with a building that the client loves and that will be there for a long time. The building is as I say, very public. We have received nothing but compliments for it from everyone who walks past, and I've stood looking at it from the other side of the river, and people have come up and said, how beautiful it is, not knowing that I'm the architect. It's also now already a known landmark where the local rowers spot it as a place where they actually sort of lift up their oars to enable them to slow down and get round the bend. So it serves a purpose for the public, at least the rowing public, anyway. And
on that public notion as well, what you can't quite see here, but it's just off to the left there. There is a public footbridge, a very large one, and there was throughout the building process, there was an audience of people just standing there and watching us and taking photographs of us. It was a bit galling, but they were all very nice when you snuck over and, as Jeremy says, go to talk to them and pretend you're not who you say you are. It's they're very complimentary.
And it's been a fantastic project to work on. We've really enjoyed working with Luke and with Laurie, and the client is coming up. Well, we're coming up with a design for a 7 to 8 meter long cantilevered roof made out of timber with a minimum of fixings. So it's actually this building, hopefully, I mean, as Laurie has said, there are elements of it which mean that it's not been the cheapest and it's been pretty labor intensive. But I think we've all learnt a huge amount from doing it. And the next stage is not to rest on our laurels, but to see if we can push this technology a little further and see what else we can do with, with wood. How far can we push it using traditional techniques and a minimum of materials and make it recyclable? And if Laurie and Luke don't have anything else to say, I think we're probably sort of at the end of the first stage where I might stop sharing, and then we're able to answer some questions.
Thanks, Jeremy.
Thank you. Well, yes, thank you very much to all three of you. We do have a lot of questions. Actually, Jeremy, you just now touched on what I wanted to ask, which was, how applicable is this learning to other projects? And you touched on that just now. I was wondering if there are larger projects where you could see, some of these lessons, some of these techniques being used.
I certainly do, and that, as I say, the next project hopefully is a step further from that. Whereas the first one is a kind of how would I say, not a safe, but a sort of from a structural point of view, it's reasonably unambitious in that we're not spanning great distances. We're not trying to minimize the size of members and striving for sort of 21st century slenderness and elegance. It was an honest structure that we wanted to see if it was possible to build a building in that way. I think now we've seen it is our natural curiosity, and we will be getting in touch with Laurie and Luke to look at this again, is how far can we stretch this? And the client is a very enthusiastic chap, very excitable, but also gives us very difficult briefs. And the brief we have for this next building, which is a carport, is that it can provide a roof over 3 cars, but it basically doesn't want any walls around it. So how do you do that? And by perhaps building we're trying to form a cantilever that will have a triangular roof, a traditional pitched roof in copper, that will extend very much like the jib on a crane out from a little storeroom and cantilever 7-8 meters across to cover the cars. And we think we can do it. Our initial discussions with the engineer think we can do it. Luke might sort of you know, have some thoughts on it when we actually show them the drawings. But yeah, we're trying to now progress and use those techniques in a more ambitious way.
Yeah, Matt, if I just kind of carry on what Jeremy was saying on that question, I think you're right. I think when it's smaller section, you know, a kind of relative scale of kind of, you know, a house or a size that this has, I think it's definitely possible. And, you know, it's almost, everybody should be trying to reduce the amount of metal work and steel and things in projects. But I think when it gets to more ambitious scales of the project or the scheme, I think that's when there are definitely some really big challenges to have. And I think we can take some of the intent, the design intent that Jeremy had and the client had forward to kind of push the boundaries on some of those bigger projects. It's really easy to go and get a big bit of steel or a big screw or something, and that can work in lots of scenarios. But actually, to try and do something a little bit different, where you try to reduce that as well, is a really interesting and really exciting opportunity.
Yeah, and I think one of the things about design is trying to. I mean, we've had our practice for 15 years, and I've been an architect for 30 odd or whatever, and actually trying to remain interested and actually sort of stretch yourself. And you know, that there are always simpler and easier ways of doing something. You need to find the right client, of course, who's happy to go with you on that journey. But I think always try and stretch yourself, always try and stretch the brief, challenge yourself, challenge the client, and try and come up with something that's both interesting and beautiful.
And on that note, the other thing I've noticed is often a lot of these projects, to make them easier and cheaper, you have the craftsmanship is often engineered out to remove costs and complexity. Whereas this project was sort of backwards in that it's been from the beginning, it's been engineered back in. So working on a project which you can, you know, there's a certain amount of craft to it. It's been a real pleasure. It's been a real pleasure to build and flex your muscles in that way. We're all very proud of it. I'm very pleased.
Matt, I just see that there's some questions at the side. Should we go through those verbally? And sorry, can't hear you, Matt. You're off. You're still off.
Sorry, I was about to ask you some of them, but by all means, cast your eyes down them. I mean, I was just going to segue onto a question about the Lignalock, and whether that can be used for I suppose more ambitious projects. Do you have to know whether that can be used on engineered timber?
Well, I actually have the gun here because it's the one thing that everyone asks me about all of the time. So here you go. Here is your Lignalock gun. You get your. I know I'm going to ask you about CLT stuff in a minute, but you get your nails on sort of bit like a machine gun. Can it be used on more commercial projects? I think the Lignalock gun is a lot of fun and it works, and I think it's perfect for cladding and things like that. One of the issues you do run into is these nails. They don't while they're great, the ends aren't particularly they're still, you know, they're quite blunt still, so you can have issues of splitting if you're not careful about where you place it. The other issue is you don't have 100% a rate of it going all the way in, so you will then have to follow up afterwards with some overcomplicated Japanese flush saws, which in normal traditional with this particular project was absolutely fine. But I guess if you were doing a commercial project, cutting the tops off 25,000 nails might get a little bit boring. I have since seen then they have got newer sorts which have heads on them and such. So I suspect the technology is there to do a much better job now. But I think commercially it might be not necessarily the most effective way forward.
Mhm.
I also think, Laurie, they only come in 1 or 2 sizes, so there's a practical. I'm not sure if it's 1 or 2, but there's, you know, they don't come in a variety of sizes that might be needed on a more commercial scale.
And these were the biggest we had. These are the biggest that exist. I think these are 70 mil, and the floorboards were 22. So you wouldn't want to go much less than that for getting your floorboards in. So if you had something more significant, I don't know how effective that would be.
Yeah.
Thanks very much.
Should we just move down through the questions, Matt? Is that probably the best?
Yeah, well, I was sort of combining a couple of them.
Yep,
So I was going to ask about the scaffold pole piles, the scaffold poles, whether building control had any quibbles over use of those, and somebody else had asked about the load that you were expecting them to carry.
Yeah, so one of the advantages of working with Sam at Element Design was that actually one of the things we wanted to do was ensure that by the time we passed on to Carpenter Oak, the scheme was viable. So we actually did a lot of the design work pre-planning, and Sam was able then to take that on post-planning, pre-building control application, and put it into the Revit. And one of the things that the Revit can do is to weigh the building in effect. So I'm not exactly how sure how heavy the building was, but we have a local engineer here, Cambridge Architectural Research, Tyrone Bowen, who designed the scaffold poles and the number of them to be able to support the weight of the building. And the scaffold poles, Laurie helped drive them in, were driven in until they reached the rock below.
I think it was a gravel bed, but you would be hitting them in. It would take a very long time you'd go, keep going. I think about 4 meters down on each one. The moment you hit the gravel bed, they would stop dead. There was nothing you could do to get them any further.
Yeah.
So there was quite a clearly defined line of where they would go into and where they would finish.
Yeah. And this was passed on to building control by the engineer who'd done his calculations, and they were happy with it. I mean, in their view, as I understand it, you know, a scaffold pole, and it's designed to connect end to end anyway, and they were very happy with it, and I don't remember it being an issue at all.
Great. I see, Laurie, as well. You answered a question about rust and the scaffold poles. You pointed out that the poles are in an anoxic
it is the
environment.
Most commonly asked question is about the rust. But as I say, the ones that were pulled out, I mean, I think they were been there for 50 years or something. And they were pulled out when the Conservatives came to come and clean the cutout for us. We managed to get them out, and they were all absolutely fine. I mean, there were some of them had slightly discolored, but you would be amazed how solid they were still. But again, it's an anoxic environment. They're galvanized as it is. They're quite thick steel as they're going in. I mean, it'll see me out, and I suspect it'll be there, well, for a good few hundred years before it starts becoming a bit of a problem. But the building itself is designed to be you could theoretically, if you were strong enough, pick it up and move it.
And I suppose related, somebody had asked if the larch was treated, you know, close to ground at sort of river level, ground level at all.
No, so the larch was all above. I mean, maybe there was a deck that Laurie built that connected the scaffold poles up to the main frame, and that was tannalized timber, and then above that it was larch. Yeah,
it's all ventilated.
Yeah, it's all
very well ventilated. Wood can get wet, and it can get dry, but it can't sit wet. And there's at no point does it not have an area where it can't dry out comfortably.
Yeah, I was gonna say any of the connections where, like Laurie was talking about, those screens, for example, they're all set off of the main beams, so there's plenty of ventilation through. So right from early on, the design, very early on, the design intent, we built in to make sure there was either weep holes for any places where we thought that water potentially could sit, or if there was areas where we knew we needed to have ventilation on vertical sort of abutments and connections, they were all spaced off. So as Laurie said, it was designed right from very early on to allow for natural ventilation.
Great. A couple more timber direct questions. Was it visually graded?
Yeah, so it's visually graded from the sawmill. I'm pretty sure it was C24. or C18. I can't remember what the engineering was on it. But yeah, it was visually graded timber. I did also see one about steam bending them, which was quite an interesting comment. So I think part of what Jeremy was talking about earlier about the size of and why we had a connection on the common rafters was because if we didn't have a connection, we'd have to get a very big piece of timber and cut it from that. So we split, or the common rafter was split into two, and then we had a connection on there, and that meant that we could get out timber that was readily available, the width and the size of it. So it didn't need to go through any extra processing. I think you wouldn't be able to steam bend a piece of that thickness anyway. It would have to go down to become a glulam piece if you wanted to do something like that. But because we reduced the section size of it and reduced the length of it, we could then make it out of solid section.
Mm-hmm. Question about the timber used for the sole plates. Was that also larch? Brackets, it says what timber was used for the sole plates sat on the pile spreader plates.
And that was are you talking about the tannalized timber?
Yeah.
But I suppose it would be, yes.
Yeah.
Okay.
That was tannalized softwood, wasn't it?
Yeah. There's nothing very exciting about that.
Okay. Okay. Somebody has asked if you could recap, just go back over the cambering of the screen timber.
Yeah. So I don't think I explained that very well. So all the timber was cut. It was all stacked into piles. And as you
Shall I get an image up? Yeah,
please. Thank you. Yeah. Every single bit of timber that you cut has some sort of a camber, one way or another. So you have to pick up every single one. You look down it. If you look, it won't be a lot, but you'll notice it'll curve one way. And where it is at the moment, you didn't want the curve to be curving outwards, i.e. away from the building, because as it gets wet and it expands, it will start pushing away from the building. So what was the intention is that all those uprights, the camber of the timber, the slow, gentle camber of the timber pushes towards into the building, and then you have the support in the middle running across, which means as it gets, as theoretically in time, it will bend a little. It gets held by the bar at the back, and that way is when you, as I say, now you will go and have a look. They are all still run in line with each other. They're not. There's not some sticking out, sticking in. Obviously, the middle rail, the camber is the other way, so they're pushing against. They're pushed against each other, but it keeps them all straight.
Great, thank you.
I hope that answers the question.
Yeah, I'm sure it will. If there's a couple more questions, so if it's all right with you guys to just overrun by a minute or two, because then we can get through them all. Very specific question here. There was the idea for the doors to open up like wings, but wasn't implemented. Was there the option of hinging the doors on a vertical axis, like usual house doors? Did you think of exploring that?
We had a conversation about it, and we did discuss the notion of wooden hinges. But in the end, what the client wanted was that the whole side of the building could be opened up. I think he was quite seduced when the building had a roof on, and Laurie was in the process of making the screens. And he thought, actually, the building completely open along the side during the summer allows people just to flow in and out of the building, rather than sort of dodging in and out of doors. There are places round the back to store the screens while they're open. And I think that's how he decided he wanted it. But yeah, we did have that initial discussion, and we think it would have been possible, and it would have been possible with timber hinges.
See.
Or even having, we even talked about having pivot doors as well, but the possibility of wind and children's fingers, it was primarily a family use building, and it didn't want to start creating more problems than it was intended.
And we have a non-timber question, a question about the copper. How were the copper standing seam panels formed? Specifically the stud edge, as that's curved down the fall of the roof.
With great difficulty. They were rolled out with the machine, and they were curved up. And as you say, when you put a standing seam on and you try and curve it out, it created no ends of headaches for the copper chaps. But it is as it sounds. It just took a very long time. They had to do quite a bit of beating to make sure it gets, would sit on nicely, but bear in mind it's a full sheet as well, so you don't want to get dents in it either. So it was very complicated.
There's also a slight sort of historical edge to it, in that the initial plan was to have copper shingles, which would have been much easier to adapt to the curve. But actually the price that we got back for forming all the individual shingles was exorbitant, and we're talking at least 50% more than it cost to actually install the roof from the straight sheets. So it took a little longer, but it saved quite a substantial bit of money.
Could you have used wooden shingles?
We could have done, and perhaps we should have done, but the client has an obsession with copper. So his house up the other end of the garden has recently been extended, and there's a lot of copper on it. So it's down to personal taste. Yeah, yes, we could have done timber shingles and pegged them on with a nail gun or something like that. So it could have been possible.
I did notice you did say that the copper was reused. So where did it come from?
I think, if I remember correctly, it's a company called Seager, and it's 100% recycled from other sources, i.e. sort of cables, things like that, then made into sheets. Yeah.
Great. Well, I think we've got through.
I think there's one more question I can see about the timber fixing to secure the common rafters to the top plate, and did you have to use screws?
That's cropped up since I last looked, but yes.
No.
So I think most of the fixings were pegs, wooden pegs, either round ones, you got some there, and some of them were actually square shaped, weren't they?
Yes.
So there were the majority of the fixings, the sort of large members connection design was mortise and tenon, and where there was always bird's mouth put on, so it kind of wasn't reliant purely on a fixing to secure it in place.
Great. Well, thank you very much to all of you. I'm just going to share my screen again to just let everybody know about the next webinars coming up. So yes, our next one is on the 7th of August, and that will be Eton Sports and Aquatic Centre. Very impressive project. I can show you a few images from that one. you can register for that now. But yes, I'll thank the panel again for a fantastic, fascinating, really interesting presentation. Lots to think about there. And thank you, everybody. Have a great afternoon. Goodbye.
Thanks.